Good morning. It is Tuesday, April 21st, and this is day 2 of finding cost or mass or weight by calculating volume and using unit analysis. This is modeling volume in your volume and three-dimensional objects packet. We did 1 and 2 together yesterday. I asked you to do 3 and 4, so let's go over something. Let's take a look. Let's do let's do them both. So number 3, a town in upstate New York keeps sand in a silo in the shape of a cone. So I know I'm working with a cone. Let's get my pen tool. I don't know where it can work. They use this sand to help de-ice the roads after a snowstorm. The silo has a diameter of 18.6 meters and a height of 0.7 kilometers. I see meters, I see kilometers. That's an issue. Step 1 is to make sure all the units match. Right now they definitely don't. So do I want meters or do I want kilometers? I need to kind of read ahead. I want cubic meters. So I'm going to have to convert the 0.7 kilometers to meters. So if I write the kilometers on bottom, I'm converting kilometers to meters. There's 1,000 meters in 1 kilometer. I'm left with 0.7 times 100, times 1,000, which is 700 meters. So the diameter is 18.6. The height is 700. So my first step is to find the volume of a cone. I go to my reference sheet, which is very blown up right now. My cone is 1/3 pi r squared h. So V equals 1/3 pi r squared h. V equals 1/3 pi. The radius is half of the diameter, which is 9.3 squared. The height is 700. I use my calculator. Again, for these problems, 99% of the time for a type of question like this, you're going to be typing pi into the calculator because it wants the answer as a number, not just in terms of pi. If it's just a regular, like, find the volume question, then maybe it's a 50% chance that it'll ask it in terms of pi. But for these modeling questions, they really wouldn't make sense to ask it in terms of pi. 1/3 pi 9.3 squared times 700 is 63,400, ... And then units again are very important. These are cubic meters. So now I begin unit analysis. I have 63,400 cubic meters. And now I'm looking for cubic meters, and I see it right here. 1.2 ounces per cubic meter. So cubic meter goes on bottom. Ounces goes on top. 1.2 ounce per cubic meter. Cubic meters are gone. Now I have ounces. I'm looking for ounces. I see it here, 12 cents per ounce. So ounce goes on bottom, money goes on top. 12 cents for 1 ounce. Ounces are gone. I have money. I want money. It's asking for cost. So now I'm done with my unit analysis. I'm going to look and see if there's a quantity or a percent. It wants me to fill 80% of the silo, so I'm going to multiply by 0.8. Remember, you always have to make the percent into a decimal by dividing by 100. So now I just go to my calculator. I like to get in the habit of using alpha y equals enter for unit analysis, even though in this case I don't have anything on bottom. I copy and paste my previous answer. Make it 1.2, 0.12, 0.8. There's nothing on bottom, so I'm just going to put a 1. To the nearest cent is what you're supposed to round to, unless it specifies otherwise. That'll be 7303.74. One thing I want to point out, which I should have done, which I didn't do, make sure there's a dot, dot, dot here. I'm not multiplying by 63,400. I'm multiplying by 63,400.48134. You need to have all that there because it will change your answer. And that's it. What did we do? We started by converting to make sure the units were all the same and their units were all what they wanted it to be. I found the volume using the volume formula. I then used unit analysis. Number 4, we have 2 concrete sections. Each section is 36 inches by 36 inches by 4 inches, so everything's inches. However, it wants the volume in feet. So I'm going to have to convert the inches to feet. I'm going to have to convert 36 inches to feet and 4 inches to feet. Inches goes on bottom. I'm converting inches to feet. You're expected to know this conversion. There's 12 inches in 1 foot. Inches cancel. I have 36 over 12, which is 3 feet. Here I have 4 over 12, which I'll leave as 1/3 feet. So I'm going to kind of replace those with the feet. So this is a rectangular prism. Rectangular prism is length times width times height. 3 times 3 times 1/3. You can use the calculator. I don't need to. That's going to be 3 cubic feet. So now that I have the volume, I begin unit analysis. I'm looking for cubic feet. I see here 325 per cubic foot. So the cubic foot's going directly to money. No mass or anything in this example. 325 for 1 cubic foot. Cubic feet are gone. It's asking for cost. I'm done with cost. I'm done with unit analysis. Now I'm looking for a percent or a quantity. There is a quantity. There's 2 of them. So I'm going to multiply by 2. Alpha y equals enter. 3 times 3.25 times 2. There's nothing on the bottom here, so I just put 1. And I get 19.5. Now with money, 2 decimal places. 1950. Whenever you're dealing with money, there's always 2 decimal places, so if you get 1 decimal place, you have to add a 0. And that's it. So hopefully you got those right yesterday. Let's go through a couple more problems today. 5, 6, 7, 8. Yeah, let's do 5, 6, 7, 8 today. So I'll do 5 and 6 for you. You know what? I'm going to do 5 and 7 for you. 7 is definitely a tough question. So I'm going to do 5 and 7, and then you'll do 6 and 8, and we'll continue from there. So a cylindrical casing is to be put around a garbage can in a busy street in Manhattan. So you have a cylindrical. Now, if this thing is going around a garbage can, you have to kind of envision this here. It's going to be hollow, because how is it getting around this garbage can if it's not hollow? So whenever we have something hollow, remember, I want to see a cross-section of it. The diameter is 25 inches. So let's just check units. Inches, 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 cubic inch. So my units are good. I don't have to do any conversions at the beginning here. So the diameter is 25. The height is 40. And the casing will be 1 inch thick. So what that means is this is 1 and this is 1, which makes the inner diameter 25 minus 1 minus 1, which is 23. So there's 2 cylinders. They both, whenever you have hollow, they're always the same height. The big one has a diameter of 25. The small one has a diameter of 23. And again, where did that come from? That came from my cross section right here. If it's 1 inch thick, then I'm subtracting 1 inch off of both sides. When I do that, I end up with an inner diameter of 23. So now I'm going to find the volume of both cylinders. This is from your reference sheet. I don't feel the need to flip back. Again, the radius is half of the diameter, so for this one it's 12.5. And for this one, it's 11.5. I go to my calculator. I have pi 12.5 squared times 40. And I can copy and paste this to make it a little bit easier and just change the 12.5 to the 11.5. So I have 19,634 dot dot dot. And I have 16,619 dot dot dot. And because I'm finding displaced volume, because it's hollow, I'm subtracting. I'm subtracting that hollow, empty cylinder out of the whole cylinder. So when I subtract them, I'm just going to copy and paste. Again, you don't want to round to the very end. Minus this. I get 3,015 dot dot dot. And this is cubic inches. So again, we did a lesson on displaced volume. Whenever you have something that's hollow, we want to draw a cross-section to help us. We're basically subtracting the thickness off of both sides to get the diameter of the inner cylinder and the height of the two cylinders, or the height of the two objects. Whenever you have volume is always the same. Whenever you have hollow is always the same. So now I have cubic inches. I'm looking, it's time to start unit analysis. I see grams per cubic inch. So cubic inch goes on bottom, grams goes on top. It's 0.841 grams for 1 cubic inch. Now I have grams. It's asking for mass. Mass is grams. Is there any quantity? Is there any percent? No. So I'm just doing 3,015 dot 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 times 0.841 times 0.841, and I have it. I should have specified what to round to, so I'll just round to the nearest gram, I guess. 2536. So if you need to, refer back to the compound and displaced volume lesson. If you're confused on what we did, if you're confused on what we did over here, otherwise, if you remember it from that lesson, to find displaced volume when something's hollow, draw a cross section to help you. You're finding the volume of two shapes and subtracting them. From there, once you have the volume, the whole gist of this lesson is then use unit analysis and go from there. All right. Just looking ahead at number 8. Number 8, we have hollow chocolate spheres. So you're going to do a similar procedure for number 8. But I'm going to let you do that on your own. Just one little hint I want to give you on number 6. It's telling you that the circumference is 31.416. So on the reference sheet, you have the circumference formula right here, C equals pi d. So what you're going to have to do is you're going to have to, do C equals, we'll do this question. C equals pi d to start. So the height of the candle is 13. It says that the circumference of the bottom, the circumference of the circle, is 31.416. Well, that's great and all, but in order to find the volume is 1/3 pi r squared h. I need to know the radius, I need to know the height. I have the height, I need the radius. Well, using this formula, I can find the diameter. If they give me the circumference, then I'm subbing in for C. So it's 31.416 divided by pi. and that's going to give me 10 dot dot dot. So if the diameter is 10 and the radius is half of that, so I divide this by 2 and I get 5 dot dot dot. So again, if they give you the circumference, if they give you the volume, then you sub in for C, and you'll have to find a missing variable. Now that I have that, 1/3 pi 5 dot 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 squared times the height is 13. I'm going to give you 30 seconds or so to finish it off on your own, and then we'll move on from there. Okay. Oops. One third pi, copy and paste that, squared times 13 to the nearest cubic centimeter, it says in the problem, is 340 cubic centimeters. Now, what's it asking for? It's asking for cubic centimeters. There's no unit analysis that we need to do here. We're done. So if they give you volume, if they give you circumference, if they give you area, you go to the reference sheet, you write down the appropriate formula, and you do algebra to find a missing variable. And once you have the missing variable, then you should have enough information to substitute into the appropriate formula. So we're going to take a look at number 7 now. I think number 7 is one of the hardest ones in this packet. And you know, sometimes these questions have twists and sometimes they don't. And this one definitely has twists. Just to wrap your head around what's going on here, I think is very challenging. That doesn't mean you can't get partial credit by knowing the math, but you know, it's challenging to wrap your head around what's going on here. So let's kind of read through this together and then we'll get to it. A gas station has a cylindrical fueling tank that holds the gasoline for its pumps as modeled below. All right, so this is a cylinder. It's a fueling tank. It holds gasoline. Great. So I'm going to draw my own cylinder. Since I'm used to seeing cylinders a certain way, that might help. The tank holds a maximum of 20,000 gallons of gasoline. So what is that, 20,000 gallons? It holds a maximum of 20,000 gallons. 20,000 is the volume. My volume is 20,000 gallons. So if it's giving me the volume, I'm probably going to have to use algebra at some point in the problem. It has a length of 34.5 feet. Now, again, that might be confusing. What's the length of the tank? Well, this is the length of the tank, which is the height of the cylinder. A metal pole is used to measure how much gas is in the tank. Okay, I guess that's what this is here. To the nearest tenth of a foot, how long does the pole need to be in order to reach the bottom of the tank and still extend 1 foot outside the tank? All right, so this is 1. And the question is, what mathematically is this? The pole is going straight through the side of the cylinder. What that represents, whatever this distance is the same as this distance. What that's asking for is the diameter. The diameter is what I'm trying to find. And again, once I find the diameter, I'm going to have to add 1 to it, since it said that it wants to stick 1 foot outside the tank. So I think the hardest part here is wrapping your head around what it's asking for. In order to find the length of this pole, I have to find the diameter of the cylinder and then add 1 to it. So it gave me the volume. The problem is it gave me the volume in gallons. I need to be in feet or cubic feet. So there's a conversion here. So from the very beginning, I'm going to have to do that conversion. So it gave me gallons. I need it to be in cubic feet. So gallons goes on bottom, cubic feet goes on top. 1 cubic foot is 7.48 gallons. Gallons cancel. I have 20,000 over 7.48. 20,000 over 7.48 is 2673 dot dot dot, and that's cubic feet. So that's the volume of this tank. So volume of a cylinder is pi r squared h. Since this is the volume, I'm replacing V with that. My radius, I don't know. My height is 34.5. My units are all good at this point. I have cubic feet, I have feet. Now I have to do algebra. I'm dividing by pi 34.5 to both sides, since I have to solve for r. Pi's cancel, 34.5's cancel. I have alpha y equals enter, 2673 dot 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 divided by pi times 34.5, 24 dot dot dot. That's great, but I don't want the radius squared. I need the radius. I take the square root of both sides. Again, I'm not rounding until the very end. I get 4 dot dot dot. Now that's great, but again, I need the diameter. So I'm going to multiply that 4 dot 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 by 2. I keep in mind, I'm writing 4 dot dot dot. It's very close to 5, so understand that. That's going to be 9 dot dot dot. Now that I have the diameter, that's the distance from here to here. The pole, it wants to be 1 more foot, so I'm going to add 1 to that. And my answer is 10.93366 dot dot dot. It wants the answer to the nearest tenth. That's going to be 10.9 feet. So again, I think this might have been one of the hardest questions in the packet. What did we do? It gave us the volume. So since it gave us the volume, I substituted into V. However, since it gave me the volume in the wrong unit, I had to start by converting to the proper unit, which was cubic feet. Once I had that, again, I substituted in for V, and I solved for R. Once I had R, I was able to find the diameter by multiplying by 2. And again, I think the hardest part of this question was wrapping your head around what it's asking for. It wants the length of this stick. Well, this stick, again, is the diameter plus 1. So once I found the diameter by multiplying by 2, I added 1, and I got my answer of 10.9 feet. So what I want you to do for homework, I'd like you to try number 9. You know what? I'd like you to get up through, so we did, what's left? So we did 5, we did 6, we did 7. I want you to try 8 through 10. And we'll go over those tomorrow. So your classwork / homework is to finish numbers 1 through 10. And again, this is modeling volume. In your volume and 3-dimensional objects. Packet And you know what I'm going to do? How much we have left after that? I think I'll give you 2 days to complete that. And then after that, we have 11, 12, 13, 14, 15, 16. Yeah, so I think I'm going to give you an extra day. So let's get that done, your classwork / homework for Tuesday and Wednesday. Because I know these do take a lot of time, so I do want you to, really spend some time and sit down with it over the next couple days. Um, so I'll give you a couple days to do that, and then on Thursday we'll go over those examples. We'll do a few more. We'll do a few more on Friday, and we'll do a 1-question quiz on this on either over the weekend or Monday. If you have any questions, reach out to me on Remind. Again, to find cost or mass or weight, we start by making sure the units are all good. Convert if necessary. So for example here, it wanted cubic feet. It gave us inches, so we had to do the conversions. Once you have the conversions, the unit's good, you find the volume. Once you have your volume, you use your unit analysis. And if it gives you the volume, then you sub into the volume and you do algebra to find whatever it asks for. That applied for 7, and something similar on 6. If it gave you the circumference, same thing, you're subbing in for the circumference, and you're doing algebra to solve for a variable. Again, this is not an easy topic. It's not. I don't know. It's a common 4 and 6 point question on the geometry region. So it used to be 6 point questions. They don't ask 6 point questions on them anymore, but they always ask 4 point questions. And the more you practice, the better. All right, that's it for me. Ask me any questions you have on Remind, and enjoy the rest of your day.